Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about domain, range, and real-life applications in algebra. In this video, we're going to talk about, is it a function? We're going to identify domain and range. We're going to talk about a real-world linear function. We're going to talk about the domain of a real situation. And lastly, we're going to graph shape from a function. So, when you're ready, let's get started. Determine if the relation 2, 3, 2, 4, and 3, 5 is a function. What I'm looking for here is to see if one input goes to two different outputs. It's mapped to that. And I noticed something here. We have 2 repeated as an input, 2 and 2, but they're mapped to different outputs. 2 is mapped to a 3, but it is also mapped to a 4. This part's fine, 3, 5, because there's no other 3 as an input here. But since we have a 2 mapping to 3 and to a 4, our answer is no. It is not a function. So again, because our input of 2 is mapped to 2 different numbers, 3 and 4, we would say no, this relation is not a function. For the function f of x is equal to 3x plus 5, where x is any real number, find the domain and range. Let's first talk about the domain. We want to see, is there any restrictions of an x value that we can plug in of a real number and for x into our function? And there really are no restrictions here. There's nothing that we cannot plug into our function here that would give us something that's undefined, like, the dividing by 0, or something we can't do, like an imaginary number, square root of a negative number. And so in this case here, our domain is all real numbers, all values can be plugged in for x, okay? And so we can write it like this. We can say negative infinity is less than x, which is less than positive infinity. And this tells us that x can be any number, any real number we want as our domain. What about our range? Okay. Well, let's think about this. Is there any value that we plug in for x, an output value that comes in that we can't have? When we think about how this is moving, as we put larger and larger numbers in for x, this function gets larger and larger and larger, the output. And if we get more numbers that are negative, 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 we get more and more negative numbers. Negative 100, and for x, we get a big negative number. Okay? And if we look at the graph really quickly of this function, it does something like this, right? It kind of shoots up like that. This is our x and our y. And so for left to right, that's our domain where it exists, all real numbers. And then our range up and down is going to be all real numbers as well, all real y values. So we can write like this. So from negative infinity to positive infinity, y can be any value in between, and that is our range. So again, our domain here is all real numbers for x, and our range is all real numbers for y. A company charges a base fee of $25 plus $7 per hour. Let f of x represent the total cost for x hours. So we'll write our function here. F of x is equal to, we have 2 fees here in place. We have a base fee of $25 and a changing rate fee of $7 per hour. And this is the one that's going to be changing by x, the number of hours that we're renting, right? This, whatever it is, okay? And so we have $7 times x, the number of hours that's being rented, right? Plus this base fee, that's a constant, it's always there. You just, no matter how many hours you rent, you just have the one-time fee of $25 right there. So again, we have our base fee of $25, and then the variable changing fee based on how many hours we're borrowing whatever the item is, right? It's $7 per hour, and that x value changes, and that will increase. So as you rent for longer, this will increase, but that one base fee stays the same. So our function here is f of x is equal to 7x plus 25. A delivery service charges $5 plus 50 cents per mile with a limit of 100 miles. Let f of x represent the total cost. What is the domain? Now here in this problem, they're only asking us what the domain is, not to find our function. We could find our function to represent it, but they're only asking us here for the domain, so let's only find the domain. So our domain here, right, is the restrictions of our input, what's changing, the variable here. And that's when we're talking about the per mile, 50 cents per mile. And it tells us a limit of 100 miles. So the lowest amount that we can deliver is going to be 0 miles, right? We can't deliver negative miles. It's impossible. 0 miles, it can equal that, right? We can hypothetically just live right there. You know, technically there's no actual 0, but for this case it's fine here, 0 miles. And x will represent the number of miles to a maximum limit from the problem here of 100. And so here we have a domain showing that from 0 to 100, including those values, this x value here is the distance in miles that the delivery service will deliver. And that's our domain for that function there, from 0 to 100 miles. Describe the graph of f of x is equal to the square root of x, where x is greater than or equal to 0. Okay. Well, we have a starting point here. They tell us our domain is x is greater than or equal to 0. So if we plug 0 into our function, and for x, the square root of 0 is 0. So it starts at the origin. 0, 0. We know that's our starting point. It starts there. Our domain here, they tell us x is greater than or equal to 0. Okay? So they tell us here already x is greater than or equal to 0. There's our values that x can be. What about our range? When we look about the values that are even plugged in here, they're all going to be 0 or greater, positive numbers. And so the square root of those numbers will also be positive, right? We saw that the lowest value was going to be 0. And it can kind of go on forever. No matter if we keep plugging in larger numbers in for x, the output of our function is also going to be a large number, right? Diminished, but it still will keep getting larger and larger. So our range here is y is greater than or equal to 0. Okay, so how can we describe this, right? So our function here maybe starts at 0, 0. It's always increasing. It's keep getting larger. As x gets bigger, this output gets larger and larger. Always increasing. But it's not linear. It's not linear. It's not a straight line, right? The square root kind of changes that. And it's also not exponential. And so this graph looks something like this, if you remember. It kind of starts at the origin and kind of does something like that. It's always going to be increasing, right? It's always increasing. It starts at our origin, 0, 0 here. It's always increasing, but it's not a straight line, not linear, and it's not exponential. It goes like this. It's our square root function. It kind of comes like this. It looks like it's going to go flat, but it's not. It's always going to keep increasing and increasing. All right? So we describe the graph for a function, f of x, square root of x here. It starts at the origin. It's always increasing, and it's not linear, and it's not exponential. Let's recap what we've learned. We first talked about, is something a function? Then we identified the domain and the range. We had a real-world linear function. Then we found the domain of a real situation. And then we determined the graph shape from a function. I now leave you with this bonus question. The height of a plant in centimeters after x weeks is given by the function f of x equals 2x plus 10. What is the height after 4 weeks? What is the domain of this function? I hope you learned something here on the domain, range, and real-life applications in algebra. And as always, thanks for watching.